Next problem is a man is crossing a river flowing with velocity of 5 meter per second. He reaches a point directly across at a distance of 6 meter in 5 seconds. His velocity in still water should be. See, a man is crossing a river flowing with velocity. The velocity of the river is this one. He reaches a point directly across at a distance of 60 meters. He reaches a point directly above this one, which is at a distance of 60 meters in 5 seconds. The time taken is 5 seconds. His velocity in still water. What is the velocity in still water? See, velocity of the river is given, distance is given, exactly opposite distance. He took 5 seconds. Then, in the absence of this flow, what is the velocity? See, to reach this point, he has to begin at some angle to this particle. Okay, then this becomes v. That is, the velocity which is going is v, and the water velocity is u. Then he reaches this one. Okay, see here, and time taken is distance by velocity. Here, if you take this right angle triangle, then this side becomes v square minus u square. This is the what the with which he, this is the velocity with which he is traveling. Okay, then simplifying this one, we get v is equal to 30 meter per second. Okay, false. Then this becomes 144 v square minus 25 becomes 144 v becomes 30 meter per second. See, next problem. A river is flowing due east with a speed of 3 meter per second. A swimmer can swim in still water at a speed of 4 meter per second. That is, velocity of swimmer in still water and velocity of water is given. If swimmer starts swimming due north, then the resultant velocity of the swimmer is dash. See, for this type of problems, there is nothing to work out. See, east direction and north direction, they are perpendicular to each other, and one velocity is given and the second velocity is given. The resultant, it is not actually a relative motion. This is vector addition. Simple. Okay. This is v, this is the water, this is the swimmer. Then resultant velocity is this. By seeing those figures, we have to simply keep the answer as 5. By seeing 3 and 4. Okay. If you solve the problem, it goes like this. Okay. Very simple. Next one. A boy can swim in still water at 1 meter per second. He swims across a river flowing at 0.6 meter per second, which is 336 meter wide. If he travels in shortest possible time, then what time he takes to cross the river? Shortest possible time. See here, to understand this one, we are going to have time distance by velocity. If it comes like this, v square plus v square. If it goes like this becomes v square minus u square. As t should be smallest, it should be highest. That is, we have to take root of v square plus u square for shortest time. Okay, we have to keep it in mind this simple logic, because what is the criteria for shortest time and for shortest distance? These are the two things. Then substituting these values, we come across. See, we start this one. See, 336 by root of 1.36. 1.36 is We know 1.12 square is 144. This is, it is it is between 1.2 and 1.2 and 1.1. That is 1.1 is 121, or 11 square is 121. 12 is closer to this one. That's why we get this one, and it is closer to. At this stage, we start the answer and we go for options. If depending on the options, we have to choose an answer. Here it is 336. Next one. A man can swim in still water with a speed of 2 meters per second. If he wants to cross a river of water current speed √3 meters per second along shortest possible path, then in which direction should he swim? Okay. Water is flowing with this velocity. He has to, in order to see shortest possible path, that is, he has to move in a perpendicular way to this water current. Then, if he want to move in this way, he have to start like this. Then, from this one triangle, we can get sin theta is equal to this one by this one, because we write the theta value in terms of known values. Velocity of water by velocity of man, √3 by 2, that is 60 degrees. This angle is 60 degrees. With respect to current, 90 plus 60, 150 with water current. Next one. A person walks at a rate of 3 km per hour. Rain appears to him in vertical direction. That is, velocity of rain with respect to person. Okay. At this velocity, find the magnitude and velocity of time of true velocity of rain. We have to find the true velocity. That is, we have to find this one. See here. It appears to fall like this. Velocity of rain with respect to person is like this. Then we are having velocity of person, velocity of rain with respect to person, velocity of rain. Velocity of rain with respect to person is velocity of rain minus velocity of person. Therefore, velocity of rain is equal to velocity of rain with respect to person plus velocity of person. At 90 degrees, it is simply we can, from these two values we can get 27 plus 9, that is 6 kilometers per hour. Then from this triangle we can calculate tan theta is equal to this value or this 1 by tan inverse of we are having this velocity of rain 3√3 by this one. This is 3, that is of course in reverse direction. Okay. Theta from vertical. From vertical it is at an angle 30 degrees.